Next on the menu we have problem 16.66, which is a Doppler shift problem. Like always in these kind of problems, we will write down the generic equations for calculating the Doppler shift. The Doppler shift at frequency f prime equals the original frequency f multiplied by v sound plus minus velocity of the observer divided by v sound minus plus velocity of the source. In fact, in this case we have two parts. We have two Doppler shifts happening. So we have our bat. It's flying towards the wall at a velocity v source. It acts as a source because it emits this ultrasound wave. Let's call the frequency heard or observed by the wall f1. It is a Doppler shifted frequency, so f1 equals original frequency times v sound, and then we have the velocity of the observer. But the observer is now the wall. It is stationary, so its velocity is 0, so we don't have this term here in this case. Continuing, v sound, and then we have a v source. What about the sign here? These two objects are approaching each other, so we'll use the upper sign, in this case minus. And then the second part, we still have our bat flying. Towards the wall, and we have the wall here. Now what happens, the wall is emitting the reflected wave at frequency f1, and it is heard by the bat as frequency f2. Now the bat is the observer, and the wall is the source. So in this case, the source velocity is 0. And we get the Doppler shifted frequency heard by the bat is the f1, f2 equals the frequency emitted by the wall, f1, times v sound, v observer, and these two objects are still approaching each other, so we use the upper sign, v plus, divided by v sound, and like I said, the v source is 0, so we don't have anything there. So what is f1 in these equations? We solve it in the first part, which is this term here, and we will input it to f1. So we'll just do that. So f times v sound divided by v sound minus v source, and then the second term, v sound plus v observer divided by v sound. Okay, so this is the first part. So what is the velocity v source? It's in fact the velocity of the bat. So let's change that, because bat was the source in the first case. And in the second case, what is the velocity of the observer? The bat is the observer, so this is also the velocity of the bat. Now, in this expression, the velocities of the sound cancel, and we have in total just the numerator from here and the denominator from here. V sound plus V bat divided by V sound minus V bat. The original frequency was 33,000 Hertz. V sound is 343 meters per second. The velocity of the bat, 9 meters per second. Okay, can you tighten the space here? So we have 343 meters per second minus 9 meters per second. And this equals about 34,800 Hertz.